Welcome to David Alexander Maths Tuition. This is chapter 4b where we're expanding a plus bx to the power of n. So all the examples we saw in the previous chapter were slightly different to this one because here the number here is a 4, not a 1. So what we need to do first of all is turn it into a 1. So by doing that we are going to just factor out the 4. So 4 plus 3x is 4, lots of 1 plus 3/4 x, all to the power of negative 2. Okay, so if we expand those brackets, we'll get back to 4 plus 3x. Now, 4 multiplied by this, all to the power of minus 2, is the same as 4 to the minus 2 multiplied by 1 plus 3/4 x to the power of minus 2. Now, 4 to the negative 2, that is 1 over 4 all squared, so that is 1 over 16. So what we are doing is we're doing 1/16 of 1 plus 3/4 x to the minus 2. Now we can expand this. There's nothing new here, but we are just going to park the 1/16 on the outside. So that is going to be 1 3/4 times negative 2 minus 6 over 4, or minus 3 over 2x, plus minus 2 times minus 3 times 3/4 x all squared, all over 2, and that's going to be plus minus 2 minus 3 minus 4 3/4 x all cubed over 6. So I'm just going to ignore that. I'm just going to leave the 1/16 now. So that's 1/16 of 1 minus 3 over 2x. So let's sort out this fraction here. So minus 2 and a minus, so the 2 cancels with the 2, and these two minus signs we can get rid of as well. So that leaves us with 3 times 3/4 x all squared. So 3 times 3 times 3 divided by 4 divided by 4, and that is 27/16. That is plus 27 over 16x squared, and the final fraction, minus 2 times minus 3 over 6 is 1, so that can all just go. So that is 4 times 3 times 3 times 3 divided by 4 divided by 4 divided by 4, and there's one minus sign, therefore the whole thing will be negative. So it's minus 27 over 16x cubed. Okay, so now I can expand this out. So 1/16 times 1, so that's 1 over 1/16 minus 3 over 32x plus 27 over 256x squared, take away 27 over 256x cubed. There we go. So there we've done the expansion up to and including the x cubed term. Now the range of values for which it's valid. Okay, so you've got 1 plus 3/4 x to the minus 2. So therefore the modulus of 3/4 x must be less than 1. So therefore, sorry, the workings here are all over the place. Just take this down here. So multiply both sides by 4 and divide by 3. The modulus of x must be less than 4/3. There we go, and we are done. Okay, so here's another example similar to the previous one. So first of all, we need to remember that this is 2 plus x to the power of 1/2. The number is not 1, so that will factor out the 2. So that's 2 lots of 1 plus 1/2 x, all to the power of 1/2, and that is 2 to the half multiplied by 1 plus 1/2 x to the power of 1/2. Now 2 to the half will just, well, that is root 2, so that is root 2 lots of, now let's do the expansion. So that's 1 plus 1/4 x plus 1/2 minus 1/2 1/2 x all squared, all over 2, plus 1/2 minus 1/2 minus 3 over 2 1/2 x all cubed over 6. So let's forget about the root 2 for now. If I try and introduce it to some of the easy bits, it's probably easy just like leaving it right to the very end. So that's 2 lots of 1 plus 1/4 x. Okay, so I'm going to ignore the sign, so that's a half times a half times a half times a half divided by 2. So that's the same as 1 divided by 2 divided by 2 divided by 2 divided by 2 divided by 2. So that is minus 1 over 32x squared, and we'll do the same on the final fraction here. So that's 3 divided by 2 divided by 2 divided by 2 divided by 2 cubed, so divided by 2 divided by 2 divided by 2, and then divide by 6. Let me just check I've got the 1, 2, 3, 4, 5, 6 2s. 1, 2, 3, 4, yes I do. and that is 1 over 126x cubed. And we have 1, 2, got a positive number of negative symbols, so therefore it's going to be positive overall. So therefore it's going to be root 2 plus 1, well, we can just write it as root 2 over 4 lots of x, take away root 2 over 32x squared plus root 2 over 126x cubed. Okay, and the range of values of which the expansion is valid, so the modulus of 1/2 x must be less than 1, so therefore the modulus of x must be less than 2, and we're done. Find the binomial expansion up to and including the x cubed term, so same as before, so we just need to remember that this is 5 lots of 4 plus 2x all to the negative 1. Inside the bracket there we've got a 4, so that is 5 lots of 4 lots of 1 plus 1/2 x all to the minus 1, so that's 5 lots of 4 to the minus 1 times by 1 plus 1/2 x to the minus 1. 4 to the negative 1 is a quarter, so that is simply 5 quarters lots of 1 plus 1/2 x to the minus 1. So that is going to be, let me just write it up here, so that's going to be 5 quarters times by 1 minus 1/2 x. Sorry, that x looks like it's on the bottom, I'll just stick it in the middle there, plus negative 1, negative 2, 1/2 x all squared over 2, plus negative 1, negative 2, negative 3, 1/2 x all cubed over 6, and minus 1 times minus 2 divided by 2 is 1, so they can cancel, and similarly negative 2 times negative 3 cancels with that 6. So what we have is 5 quarters, and inside the brackets 1, take away 1/2 x, plus 1/4 x squared. I've been a bit slack here where I've put my cube. That cube should be outside the brackets there. So that is 1/8 x cubed. And we've only got 1 minus sign, so overall that is negative. So take away 1/8 x cubed. So expand it all out. We're going to get 5 over 4 minus 5 over 8x plus 5 over 16x squared minus 5 over 32x cubed. And the range of values for which the expansion is valid, well, inside the brackets is 1 plus 1/2 x, so the modulus of 1/2 x must be less than 1, so therefore x, the modulus of x must be less than 2, so that's the range of values where this works. Okay, let's look at one example which has got some slightly trickier questions to follow in the next part. So first of all, we know that this is 9 lots of 1 minus 1/9 x all to the power of 1/2, which is 9 to the power of a half multiplied by 1 minus 1/9 x to the half, and 9 to the power of a half is of course 3. So what we are doing is 3 lots of 1 minus 1/9 of x to the power of 1/2. So that's going to be 3 lots of 1 minus 1 over 18x plus 1/2 multiplied by negative a half multiplied by minus 1/9 x all squared all over 2 plus 1/2 minus 1/2 minus 3 over 2 minus 1/9 x all cubed over 6. So that is 3 lots of 1 minus 1 over 18x. So they've got 3 negative signs, so this would be minus overall. So 1 divided by 2 divided by 2 divided by 9 divided by 9 divided by 2 is 648. So minus 1 over 648x squared. We've got 1, 2, 3, 4, 5 negative symbols here. So again, this one will be negative as well. So we'll just do 3 divided by 2 divided by 2 divided by 2 divided by 9 divided by 9 divided by 9 divided by 6. And that is minus 1 over 1296x cubed. So now I just need to multiply 3 by 3, expand out the brackets, so that's 3 minus 1 over 6x minus 1 over 216 rather, 1 over 216x squared, take away 1 over 432x cubed. There we go, and we're done. Okay, so for the next part of the question is nice and easy. So show that when x is 0.01 or 1/100th, the exact value of the f of x is root 899 over 10. Okay, so 9 is 9 over 1, which is the same as 900 over 100. So if I'm taking away 1/100th, that is going to be 899 over 100. That is the value of 9 minus x. So all of that to the power of 1/2, well, that is the square root of 899 over 100, and that can be written as the root of 899 over the square root of 100. So therefore, root 899 over 10, and we're sorted. Okay, so from the previous question, we know that the binomial expansion up to and including the x squared term for the f of x was 3 minus 1/6 x minus 1/216 of x squared minus 1 over 432 x cubed. Okay, so when x is 0.01, the exact value is root 899 over 10. So therefore, what we can say here is that, well, 9 minus x to the power of 1/2 is exactly, well, it's very similar to this stuff here. So therefore, if these two things are approximately the same, then, and the exact value of 9 minus x to the 1/2 is root 899 over 10, then what we can say is that root 899 over 10 is approximately the same as 3 minus 1/6 x minus 1 over 216 x squared minus 1 over 432 x cubed. So if I want to find an approximation for root 899, then root 899 is going to be 10 times 3 minus 1/6 x minus 1 over 216 x squared minus 1 over 432 x cubed. So what I'm going to do is I'm going to substitute in this x value of 0.01 into my expansion. So I'll just put in my calculator 0.01 and hit an equal sign. And now I'm just going to do 3 minus answer divided by 6 minus answer squared divided by 216 minus answer cubed divided by 432, and then multiply that by 10. So what I'm getting is that root 899, these should have been approximation signs, by the way, not equals. Root 899 is approximately 29.98 to 2 decimal places. Now let's see if we're right. On my calculator, I'm going to type in root 899 and square root it, and hopefully I get a value that's pretty close to 29.98, and I get 29.9833287. Perfect. So always good when you know you can check it on a calculator just for comfort, so that you know you got the question right, and in this case we definitely have. Okay, so this is a fairly horrendous example. I need lots of working out, which is why I've had to make it, the font very small here. So we're subtracting 2 over 3 plus 2x from 5 over 4 plus 3x. So first of all, I'm just going to expand both of these separately. So on this left-hand side, I'm going to do 5 over 4 plus 3x, which is 5 lots of 4 plus 3x to the negative 1, which is the same as 5 lots of 4 lots of 1 plus 3/4 x to the negative 1, and that is the same as 5 lots of 4 to the negative 1, and 4 to the negative 1 is a quarter, so that is 5/4 times by 1 plus 3/4 x to the minus 1. So now we can do the expansion, so that's 5/4 multiplied by 1 minus 3 over 4x plus minus 1 times minus 2 multiplied by 3/4 x all squared all over 2, and the 2 will cancel out the minus 1 and the minus 2 there. So that is 5/4 times 1 minus 3/4 x plus 9/16 x squared. Expand it all out, so that's 5 over 4 minus 15 over 16x plus 45 over 64 rather, x squared. Okay, so that is the expansion up to x squared of this fraction here. I'm not going to worry about the minus, I'll deal with the minus in a moment. So now let's just do the same thing. So this is 2 lots of 3 plus 2x to the minus 1. So that's 2 lots of 3 lots of 1 plus 2/3 x all to the negative 1, and 3 to the minus 1 is a third, so that is 2/3 1 plus 2/3 x to the negative 1. So that is 2/3 of 1 minus 2/3 x plus minus 1 times minus 2 times 2/3 x squared all over 2. And again, the negative 1 and the negative 2 will cancel with the 2. So that is 2/3 1 minus 2/3 x plus 4/9 x squared multiplied by 2/3. So we're getting 2/3 minus 4/9 x plus 8 over 27x squared. So this here is the expansion of that right hand fraction. So now all we need to do is subtract this stuff here from this stuff here. So 5/4 take away 2/3, that is 7/12. Minus 15x take away negative 4/9x, in other words plus 4/9x, is negative 71/144x. And finally 45/64x squared take away positive 8/27x squared. Guess what? That is plus 703/1728x squared. Okay, there we go. So we do like to show that question. So just keep hacking around until you get the right answer, obviously. And I'm pretty certain in an exam you wouldn't have fractions with such ridiculous numbers in. But anyway, this is just a bit of practice. Anyway, we've done it. So deal with, I'd say my recommendation would be to deal with the two fractions separately and then do the subtraction at the end. Okay, so continuing with this question, so find the exact value of the f of 0.03. Just substitute in 0.03. So I will probably type in 0.3 on my calculator, hit equals, and then type in 5/4 plus 3 answer, take away 2/3 plus 2 answer, and what we get is to 6 decimal places. Well, I'll just write out what my calculator says. So I'm getting 0.5688991163. So 1, 2, 3, 4, 5, 6 decimal places. That is going to be 0.568899. Okay, so find the percentage error made in using the series expansion. Now, just to remind ourselves, the series expansion was 7/12, take away 71/144x plus 703/1728x squared. So when x is 0.03, what does all this equal? So again, I type in 0.03 on my calculator. 7 divided by 12 minus 71 answer over 144 plus 703 answer squared over 1728. And what I get here is 0.56897. Okay, so actually, what's the next figure? The next is an 8. So again, to 6 decimal places. 1, 2, 3, 4, 5, 6. So that's going to be 0.568908. So it doesn't say 6 decimal places, so I'll assume it does. So what is the percentage error? Well, this is inaccurate. This is slightly inaccurate. This is, we can see it's slightly different. So first of all, so let me just write down here. So the actual is 0.568899. And our estimate, I'm just going to write it directly underneath so I can see which one is bigger. 568,908. Okay, so it's going to be the difference over the actual multiplied by 100. So to work out the difference, I want a positive difference, so I'll do big take small. So 0.568908 minus 0.568899 equals very small number. Well, we can see there's hardly anything in it here. I'm going to divide that by the actual, which is 0.568899, and multiply by 100 to get my percentage, and it's minuscule, and that is 1.58 times by 10 to the power of minus 9%. So yeah, fairly. So we can see that by doing the expansion really makes hardly any difference at all. Well, we could almost say next to no difference, and that's only going as far as the x squared term. If we went further to an x cubed term, then the difference would be even less. There we go, we are done.